Hi guys, Mr. Magda here. Just about to get started on our indices topic. Now, indices and SUDs, actually, both of them are quite tricky topics to get a grip of. But the key rules, if we can follow the key rules and use these and review these on a regular basis, then it's very easy to stay on top of. So the first thing is that really what we're looking at is an index, okay, a number that you've seen before that has a power. That power is an index, okay, and the number that's, say, subscript is the base. So in this case, indices are mathematical concepts used for expressing large numbers. So, for example, 2 to the power of 5, where 2 is the base and 5, like I said, is the index. So the little 5 that's superscript, that's the index. So the first couple of rules are nice and simple, okay, very easy to work through. And we tend to look at these rules using letters M and N. Okay, so A, M, and A to the power of N, just to highlight the rules. But they're far easier to see when actually practically going through a question. If we look at the examples in the box, they're easier to follow. So when we multiply, okay, we multiply indices, and all we do is simply add the index. When we divide the indices in example 2, then what we do is we subtract the index. So like I said, far easier to see when we go through the examples like they are in the box. So a to the power of 3 times a to the power of 4 is a to the power of 3 and the 4 added together, which is 7. Okay, conversely, if we're dividing a to the power of 6 divided by a to the power of 2, we can write that in two ways, so it's always good to refresh that. We've got a to the power of 6 over a to the power of 2 is the same as a to the power of 6 take away 2, which gives us our a to the power of 4. Okay, so if we wanted to do an additional example, we could have x to the power of 3 times x to the power of 5. That would give us x to the power of 8. Okay, where we have the 3 and the 5 added together, the x stays the same. If we were to divide, we could have, let's pick the letter P to the power of 12 over P to the power of 3. So that's 12, take away 3, so P to the power of 9. What's worth recognizing here, if we were to look at a third example, particularly when we're dividing, is if we have a double negative. So if I had m to the power of 6 and it was over m to the power of minus 2. Actually, what we have in the previous examples, I didn't go through the process of writing the 6 take away the minus 2. But what we've actually got here, we would have to be very careful. We're subtracting the powers. So that becomes 6 take away negative 2. And in there, we'd have to recognize that we've got our double negative rule. So that becomes a 6 plus 2. And therefore, you'd have m to the power 8. Okay, rather than say m to the power of 4 where you had 6 subtract 2. Something to be very mindful of when you're dividing by a negative. You can get a double negative, which makes it positive. Multiplying indices and dividing indices, we have also to consider that there'll be numbers possibly at the front of each of these terms. So I would always suggest that you tackle the numbers first and then deal with the index. Okay, so first of all, if we look at this example over here, 5x to the power of 9 times 6x to the power of 3, 5 times 6 will give us our 30. That allows us to focus now on the x to the power of 9 and the x to the power of 3. So x to the power of 9 plus the x to the power of minus 3. So again, be very careful. We're not doing 9 plus 3 because that would give us 12. It's 9 plus a negative 3. So that's 9, take away 3, which is 6. So 30 x to the power of 6. Example E. Again, deal with the numbers first. We've got 12r to the power of 5 over 3r to the power of 4. Over is a divide, so 12 divided by 3 gives us 4. 5 is the power, so r to the power of 5 and r to the power of 4. We're dividing, so it's a subtract, so 5 take away 4 is 1. So 4r to the power of 1. Now, quite often, people will leave it as 4r to the power of 1. We know at this level that we can just leave that as 4r. So I'm leaving that middle section in there, but going forward, I don't really want to see that 1 in there. Okay, it's just going to be 4r on its own, and that's something that we intuitively need to know is 4r to the power of 1. Well, moving on to a couple of more examples where we've got more than just two terms to multiply or divide. So in example F, if we look here, can look slightly more complex because we've got 3 sets of terms with coefficients. So we've got minus 3a squared times 7a to the power of 4 times 8a, which we know is 8a to the power of 1. So again, deal with the numbers first. Minus 3 times 7 is minus 21 times 8, okay, is minus 168. So we've got minus 168. Okay, a to the power of 2 times a to the power of 4 times a to the power of 1. So if we add 2 and 4 and 1 gives us a to the power of 7. Okay, G, slightly more complex as it has a multiplication and a division in it. So we need to separate those two elements. So 8d to the power of 5 times 4d to the power of 2. First of all, 8 times 4 gives us a 32. D to the power of 5 times d to the power of 2 is d to the power of 7. And now we're dividing by 16d to the minus 3. We now have our division, so 32 divided by 16 is 2. And this is another situation where we've got a division by a negative. So 7, take away negative 3 is going to give us a double negative, which is plus. So that's 2d to the power of 10, because we've got 7 minus 3 gives us 7 plus 3 is 10. Okay, the next two sets of rules include brackets with indices or an index on the inside and an index on the outside. As you can see here with rule number 3, we have a to the power m and then a to the power of n outside of the bracket. So when dealing with rule 3, we take the m value and we multiply it by the value outside, which is the n. So that's where you'll see a equals m times n, or we are used to working in algebra where if there's nothing between two letters, n tells us that it's a multiply anyway. Like I said before, a little bit easier to see when focusing on the actual numerical values rather than the letters. So in the example below, if I bring your attention to this part here, we have a to the power of 5, and the 4 is outside the bracket. So a to the power of 5, 4 outside the bracket. So we've got a, it's 5 times 4, which gives us a to the power of 20. Exam style question that you would look at is something where there includes a number inside the bracket, and this is quite important. So both terms need to be taken to the power of 4. So it's not just simple enough to do 2a to the power of 5 and the 4 is outside. So in this case, you would not do 2a to the power of 5 times 4 would be 2a to the power of 20. So if we were to take this example, 2a to the power of 5, and leave it as 2a to the power of 20, what we've done there is we've not taken the 2 to the power of 4. And if we don't take the 2 to the power of 4, then that's inside the bracket and that causes a problem. That's maybe a little easier to see if we were to expand that bracket in a more lengthy way. So if we had to take 2a to the power of 5 to the power of 4, what that actually means is we've got 2a to the power of 5 times 2a to the power of 5 times 2a to the power of 5, and keep going until we have 4 lots. Okay, so that 4 there counts for our 1, 2, 3, 4 sets. And you can see 2 times 2 times 2 times 2 would give us our 2 to the power of 4. And we have our a 5 plus 5 plus 5a to the 20. And that hopefully is something that you will see will connect up here. So 2 to the power of 4 is 16. 2 times 2 times 2 times 2. And without following that rule where we have to include the 2 in our index of 4, then you're going to make a kind of simple error. This is something that happens really, really often when dealing with NAT5 indices. So focusing on rule number 3, if I was just to give you a couple of quick examples. Of example A, if it was a straightforward y to the power of 6 in brackets all to the power of 3, then we have y to 6 times 3, or you guys would be able to jump straight to y to the power of 18. Okay, that's the kind of basement level example. What we're going to have, or you're going to see more often, is the exam type that I mentioned before. So if I have 3m to the power of 2 and the whole thing is to the power of 3, the common mistake would be to simply write 3m to the power of 6, and in that case you're just taking the 2 and the 3 and multiplying them together. But that's not what we want to do. We need to remember that we need to take the 3 to the power of 3 and the m squared to the power of 3. So if we deal with them individually, 3 to the power of 3 is 27, and then the m squared to the power of 3 gives us our m to the power of 6. So the important thing really is that we need to remember, rather than leaving it as a 3, we've got 3 times 3 times 3 to give us our 27. Okay, now we're going to focus on, as you can see up at the top, that's given any index of 0, then the answer is 1. And what I often do in a classroom is I will ask you to take your calculator out, type in as big a number as you can, make sure it goes right off the screen. So you could practically do that right now. If you take your calculator, go to the numbers and type in as big a number as you can right off the screen, and then hit the power sign. And if you make it to the power of 0, any number whatsoever will give you an answer of 1. So anything to the power of 0 is 1. It's sort of difficult to for us to focus on notes in this regard. What we're going to really see here is just a couple of examples. 5 to the power of 0 is 1. 123 to the power of 0 is 1. And this is true for anything. If we have any form of algebraic term, whether it be x, y to the power of 5, and if it's covered by a bracket and the whole thing is to the power of 0, then the answer is 1. Anything that we have that is to the power of 0 will be 1. You could pick whatever number you can come up with. So it's still a relatively small number to the to the power of 0. And if you put that into your calculator, the answer will be 1. A nice straightforward rule, but something that does crop up often. The exam type, what we tend to see for the rule 4 exam type is we tend to have a question that involves brackets, and we might have something typically like x to the power of a half times x to the power of a half plus x to the power of negative a half. Okay, now to explain how we would tackle this, we need to just recall our rules about breaking brackets. If we have a look at the blue example, what would happen here is you know that any term outside a bracket multiplies everything inside the bracket. So x squared is going to multiply x to the power of 3. It's also then going to multiply x to the power of 4. So to complete this, we would have x to the power of 2 times x to the power of 3. We go back to our original rules. If we're multiplying, we're adding the powers. That would give us x to the power of 5, x to the power of 2 times x to the power of 4 is going to give us x to the power of 6. Okay, so combination of our algebra and breaking bracket skills that we've worked on previously, and the new indices rules. Now, that blue example over there is relatively straightforward in the sense that it's only dealing with numbers, no fractions or anything like that. So the example I've given you includes fractions and negatives. If we want to look at, say, a similar example, if I was to change any of those numbers in the blue example to a negative, then you would just factor that in with your multiplication. I want to focus on this example that I've got here, though, the x to the power of half. So x to the power of half, if we multiply the brackets, multiply the terms outside and inside the bracket, we start off with x to the power of half times x to the power of half. That's going to give us x to the power of a half plus a half, which is 2 halves. Okay. The next step, x to the power of half times x to the power of negative a half, and this is the trick. If we have x to the power of half plus x to the power of negative half, or times x to the power of negative half, we're going to add the powers. So a half plus a negative half is going to give us 0. Okay, so there's two things in the exam style question here that they would be looking for. First of all, we recognize that the 2 over 2 is going to change just to the power of 1. Okay, now we know ourselves, we don't put the 1 in there. We could have a 1 in here, but we don't want that. We know at this stage that we can do without that. So we just leave it as an x, and equally the x to the power of 0, we know anything to the power of 0 is just 1. So that would simplify to x plus 1, and that means we're getting rid of this x to the power of 0 because anything to the power of 0, following rule 4, is 1.